Hello everybody, I'm Felix Twagirayezu, a tutor of mathematics in Zaza. I come with a new lesson and I wish you to enjoy. Welcome. Abanyarwanda twese umutima umwe wo gukunda igihugu no kugikorera, twese nk'umuntu umwe, igihugu kimwe, icyerekezo kimwe, dukora nk'ikipimwe. Rwanda yacu zatera imbere, iterambere ry'igihugu buri wese naryiyumvamo, rikaba nk'ishema ryenge. Rwanda yacu zatera imbere, rigena imigani inoze ntirigendera ku byihutirwa cyane kurusha ibindi. Rwanda yacu zatera imbere. As usual, this is mathematics as a subject. This lesson is designed for Year 2 Science and Mathematics Education, Year 2 SME, and the school is the Teacher Training College, TTC. I'm Felix Twagirayezu, as I told you, and down there are the numbers, phone numbers, and the email, so that if you have questions, support, any comments, feel free to give support or to ask. Welcome all. Today we are going to start unit number 5. It is part of analysis, which is unit number 5 is the functions. And the lesson of today, we are going to learn together the types of functions. And the objective for today, by using examples, by the end of this lesson, participants will be able to identify different types of functions correctly. Now let us use the diagram with the figure that we have here, and this one will help us to define some concept of a function. We have the set A and set B. The set A is containing the names of runners, and B is having the set of marks. In this case, try to think about a test of mathematics marked out of 10, and the runners shown in the set A have gotten the marks which are corresponding to them. In this case, we are going to consider the set A as the set of elements and set B for the set of images. Sorry. The set A, the set of all elements, it is called the domain. And the set of all images are called codomain. But in the set of elements, we have some elements having their respective images and the others which have not. In this set, we have Anna, Bob, Ken, John, and Saf. They are having their respective marks, but Katie doesn't have. In this case, in the subset containing Anna, Bob, Ken, John, and Saf in the red color is called the domain of definition. It means it is the subset containing the elements which are having their respective images. But Katie, in this case, is not in the domain of definition. Those elements, they have their respective images. And in set B, which is called the codomain, it is having some elements which are some images having their respective elements. And those images, they are forming a subset which is called the range. It is clear in the orange color. And in this case, let us have some definitions. The domain is defined as the set of all supposed to be elements. In the above figure, the domain is containing all elements. You can see the set in black, the domain, the set A. All the names, all the 6 runners are forming the subset which is called the domain. We have also the codomain. The codomain are all elements in B, as we saw. We can see the codomain is containing 5, 6, 7, 8, 9, and 10. Domain of definition also we have defined. Try to verify. You will find that the domain of definition is containing elements Anne, Bob, Ken, John, and Saf. We have the range also. The range you have defined as the subset, the set of all images that having their corresponding elements. Let us try to define a function. We have the figures below. I'm going to show you the figures, and in those figures they are showing in one side the runners, and in the other side their corresponding marks obtained in a mathematics test marked out of 10. Let us observe the first figure. You can see that every element there which has the image has one and only one image. You can see that Anne has 5, Bob 6, Ken 7, John 8, Safi 9, but Katie doesn't have the marks, means that she didn't sit for this test. For the second figure, we have 3 students. We have Teta, Sonia, and Fanny, where Teta has gotten 6, Sonia also has gotten 6, but Fanny gotten 9. Means that Teta and Sonia, they have the same marks. And for the third figure, we see that the student Freddy, Davi, and Anita, also they have their respective marks, but Freddy has gotten 6, has 2 images, 6 and 8. Anita also has gotten 7 and 9. Try to think critically. Can a runner get 2 different marks in one test? But in this third figure, it is shown that Freddy has 2 marks and Anita has gotten 2 different marks. Let us come to the first figure. We will see that in this figure we have Anna has 1 image, Bob 1 image, Kenny the same, John the same, Safi the same. This relationship where every element is in relation with only 1 image is called one-to-one relationship, or one-to-one correspondence, or one-to-one mapping simply. For the second figure, you can see that Teta and Sonia, they have 1 image. In this case, you have 2 elements to 1 image, and in this case we say 2-to-1 correspondence, 2-to-1 mapping, or 2-to-1 relationship. And in this case you can even find many elements having 1 image. In this case we call them many-to-1 mapping. For the third one, we have Freddy has 2 images. Anita also has 2 images. Davi has no image. when you have one element having two different images or many, we call this one-to-many mapping. Now, let us have an activity here. Considering the relationship given in the figures above, answer by using yes or no. We read carefully, and if you find the answer will be yes, you answer. If the answer is no, feel free to answer. This is referring to one test marked out of 10, and then you are asked, can one runner get 6 out of 10? Will answer yes or no. Can two different runners get the same marks? Yes or no. Can one runner get two different marks? You will read carefully and you think critically, and then you will answer to the 3 questions which are the activity, which are making the activity 1. Let me give you the time to think about this activity.
aho yagabiriye kanjogera, amugabira amashyo, amugabira abagaraga, amugabira urugo. Gasabo we uri maboko y'u Rwanda, urutare rw'uruganzu n'ibigabiro bya Gihanga, wanze u Rwanda aho yapfukamye yikora mu mitana yegera abatanazi, maze ahuza impemba amakuza arayatuma. Gasabo we uri maboko y'u Rwanda,
I think that you have answered to the activity. And let us see the answers for this activity. For A, yes, one runner can get 6 out of 10. For number B, 2 runners can have the same marks. Means that one runner can work on the test and get out 8 out of 10. And the other one also can get out of 10. But for number C, no one runner can get 2 different marks in one test. Have you won? Yes. The mapping which are related to yes in this case are the ones which are called the function. And the ones for no, they are not called the function, means they are not a function. Therefore, in this case, one-to-one mapping or one-to-one relationship, one-to-one correspondence is a function. Many-to-one mapping also it is a function, but one-to-many is not a function. And this is how we can identify a function. And let us together see how can we define the definition of a function. Actually, we can define a function mathematically as a relationship where every element and each element has one and only one image. The element which has the image must have one and only one image. You can see that the definition of a function is very simple and easy to know. Now let us go to the types of functions. In this case, we are going to give types of functions to differentiate functions according to their physical appearance. Means that when you have a look on a given function, when you read a function, when you see a function, you will know that it is this kind of a function. Now let us go to the first type of a function. The first type of a function is about polynomial functions. Polynomial functions are functions which are written in a linear form but only having the variable. Means that we could have x, y, z and so on depending on the variable which is chosen. In this case, the polynomial function is a function of the form of f of x, which is equal to a0 plus a1 plus x plus a2 x squared plus and so on plus a index n x power n. The function which is written in this form, which is looking like this, it will be a polynomial function. But in this case, the coefficient a0 from a0 up to an must be different from 0, and n, which is the power, must be a non-zero positive integer. In this case, we are going to see some examples, but you will think your own examples. The example number 1 is f of x is equal to x power 5 plus 2x power 4 plus 5x power 3 minus 7x squared plus x minus 1. 2 f of x is equal to 2x plus 3. You can see that those functions are written in a linear form, and the functions for this type, they are called polynomial functions. The second type of function is rational functions. A function is called rational when it is looking like a fraction, but the denominator part must have the variable. At least the denominator part must have the variable. Let us have the form of rational function. Actually, a function to be called rational must have this must be written in this form: a0 plus a1x plus a2x squared plus and so on plus a index n times x power n over b0 plus b1x plus b2 x squared plus and so on plus b index n times x power n, where the coefficient a's and b's, they are different from 0 and n must be a counting or a non-zero positive integer or a natural number which is different from 0. We have some examples here. Example number 1 is f of x, which is equal to x squared plus 5 over x minus 11. You can see that here we have the variable x. If we don't have the variable x, and when it is only a number, in this case it will not be a rational function, but it will be a polynomial function. Example number 2, we have gx, which is equal to 1 over 4x minus 7. Also you can see that on this denominator we have the variable. The third type of function is the irrational functions. The irrational function, it is a function which is containing the radical, and it can be expressed in the following form: n root of f of x, where n is a non-zero positive integer and also greater than 1. It is an integer which is greater than 1. Now let us have some examples of irrational functions. Example number 1 is f of x, which is equal to cube root of x square plus 5x minus 6. Because it is containing the radical, so it is an irrational function. Example number 2, we have f of x, which is equal to square root of x plus 2 over cube root of x minus 1. You can see, even though it can look like a rational function, but it is containing the radicals, means that in this case it will be called, depending on this radical, and it will be called the irrational function. The type number 4, it is about trigonometric functions. A function f is said to be a trigonometric when it is containing at least one of the trigonometric values. Remember that the trigonometric values, they are sine, cosine, tan, cotan, sec, cosec. If a function is containing one of them, in this case we will call it a trigonometric function. We have an example here. Examples. Example number 1 is f of x, which is equal to sine square x plus 4 sine x minus 8. Means that you can see that this one is containing the sine value. Example number 2, f of x is equal to sec x plus tan x. You can see that also this one is containing trigonometric values. You can give your own examples using cosine, using cotan, using cosec, and so on. You will give more examples, but the two are the only ones to help you to understand how the trigonometric functions are looking like. The next type of function is about logarithmic functions. A function is called to be logarithmic when it is containing the logarithms. It is simple. Examples, I think you have ever seen about logarithms. Example number 1, f of x is equal to log of x plus 2 minus log of x minus 1. When you are writing the log of a term, a factor containing more than 1, means from 2 upward factors, you have to write, use the brackets to help you to identify is log of what. Example number 2 is f of x, which is equal to ln of 5x minus 8 plus ln of x. You remember that ln is the abbreviation, is the short of Napier's logarithm, or natural logarithm in French, is about logarithm and Périer. That L is standing for logarithm, and N is for logarithm, is for Périer, or logarithm naturel. Napier's logarithm or natural logarithms. The next one, which is the last but not the least, is about the exponential functions. A function is said to be exponential when it is containing the exponential terms. An exponential term is a term where we have the base is known to the number and the power is containing the unknown or the variable parts. We have some examples here. Example number 1 is f of x is equal to 3 power 2x plus 3 power x plus 1. That one is exponential function because the 3 power 2x and 3 power x, they are exponential terms. Example number 2, f of x is equal to x power x. Also, because the power is unknown, in this case, this one is exponential function. Good. In this case, I have some applications. In those applications, we have question number 1, question number 2, and those questions you will do them if you have well understood, and then you will choose your own answers. Now let us have a break a bit and then we continue in few seconds.
amazi meza n'amashanyarazi yasawe mu mibereho myiza y'abagutuye, dore ibikumba by'inka mu biraro yasawe n'ubw'indengabaganizi tura abanyamugi, turahinga kandi tukorora yasawe dore amahoteli menshi yubatswe iwawe, mu bukerarugendo ntawe aguhiga yasawe maboko y'u Rwanda, urugero usabe kuko nsanzure rudasumba, soko y'u Rwanda yasawe kuri soko y'u Rwanda, urugero usabe kuko nsanzure rudasumba, soko y'u Rwanda yasawe kuri maboko y'u Rwanda. Ku musozi muremure wa Jari yatumye ubindatwa mu ikoranabuhanga yasawe ahubatswe inganda zijyanye n'igihe, ndavuga ndera ndirimba shize amanga yasawe ngeze mu gakiriro mbona uruhare rw'amakoperative mu iterambere ryawe yasawe imiyoborere myiza uri rudasumbwa, wakira neza abaje bakugana yasawe dore igishushanyo mbonera cyangwa twifuza kugera ku.
Let us come back in the activity. Question number 1 is saying that mathematically define function. You will define a function as you define it or for your own understanding from this lesson. Question number 2, indicate the type of each function given below. We are given different functions, and differing to the types of functions that we learned today, we will say that this is this kind of function and this one. The function number 1 is f of x is equal to ax power 3 plus bx power 2 plus cx plus d, where those coefficients a, b, c and d, they are non-zero real numbers. Function number 2 is f of x, which is equal to 1 over x plus 1. The function number 3, f of x is equal to sin x over cos x. The last function is f of x, which is equal to e power x, where e is a real number. It means it is a constant. I wish you success, or thank you for your attention, please. And this is the end of our lesson of today. I thank you for your attention, and we will meet for the next lesson, but I ask you something now today. Ask you something. Don't forget to subscribe so that you can get every day the lesson of every day. I wish you success. We will meet next time. Thank you. Enjoy for the next.